Brent, it's good to see you again.
You too, Brett. Thanks for having us over. I am super impressed by this house, and we're here today. We're going to tell everybody about it. Last year, you had reached out to us, and we did an energy audit. We tried to. We came to your house, and we did a bunch of diagnostic testing, and you were kind of looking for ways to see how you can be more energy efficient. And when we tested this house, I had never seen this happen. Our best solutions with the Air Doctors team would have made your energy consumption go up. All right, so that was pretty impressive, and it caught my eye, and I thought this would be an awesome time to kind of highlight you and your business and kind of about this project. So tell our viewers who you are, the collaboration, what kind of house this is, and then we'll kind of get into your interview.
Absolutely, yeah. So I'm Brett Crandall. I'm Director of Design with a local architecture firm here in Detroit, 3 Squared Inc. We're a pretty small team, and we do a lot of from commercial all the way to residential and infills, a lot of our focus on our work here. And then that was a collaboration of the architecture team with a design technology firm that I co-founded a number of years ago, and we've been studying how to actually take the unique conditions of each lot and apply them to a house early in the design process, so that we can maximize the efficiency of the pattern of the sun and the energy heat loss and gain from the different seasons, and how that impacts the house. Because just changing the roof shape on a particular lot and rearranging doors and windows has a huge impact on the energy use of a space. So we've been working on generative design, so using computer algorithms to look at that data and then produce for us a start of the design process. And so why that's different is houm, H-O-U-M, it's phonetic spelling for home, right? So what houm does is they're the front end of design. So they're gonna take the lot and really do an analysis and look at it, and they come up with basically a shell of the house. Now that house still needs to be designed completely and engineered and the actual building components. That's where 3 Squared came in.
Okay.
So this project, the Cochrane Home, was a collaboration between those 2 companies, and it was really the prototype. And so I endeavored to build the first prototype, because they say, put your money where your mouth is.
Absolutely.
So we did that. And I learned kind of the hard way. We can't build like we used to. Honestly, you can't.
You can't.
You can't find
Absolutely.
the tradespeople to work with those materials. You can't purchase the materials, and the cost. We don't even need to get into the cost. But this is as close as we can come. Honestly, from our position, multiple architects collaborating on this project, this is a testament to what we can accomplish. And it comes from natural daylight. It comes from designing comfortable spaces, using volumes instead of just looking at floor plans on a screen. And so this was really us putting all of our efforts together and putting a prototype out there. Now, this house is also unique because it's a single family residence, and then we have a patio and then a garage out back. And then above the garage, there's an apartment suite, which we rent out on Airbnb, and that's connected to the main house with a bridge. So it's really 2 buildings on one property, but we developed this on some Detroit Land Bank property. So we did get it a little bit cheaper than traditional. It came with its own hurdles. But we were able to develop a new building in Detroit on DLBA land, and we did it on time and on budget.
That's awesome.
Yeah.
That's awesome. So we're gonna look at various features of the house. This super impressive house. So this is a Cochrane Home. You physically live here, so tell our viewers, what does your bills look like now compared to your previous residence?
Oh, yeah, that's a good question. So just for some context, I've been in Detroit 17 years now. I lived in a loft in Eastern Market that didn't have AC. So I don't want to start there. It was miserable. You were struggling for your life. And then I lived in a historic home in Boston Edison, and in winter, it was the most inefficient home imaginable. We were pushing $600 a month.
Those are the houses I'm used to fixing.
Right. That's the Detroit special.
Absolutely.
They leak like a sieve. They breathe. It doesn't matter how much insulation you have on the walls if there's air gaps. Right? You're sealing something to keep the air in. So I would say, no question, I'm saving between $250 and $300 every month through summer and winter. Now there were extreme swings, but it's consistent. I'm paying almost the same through summer and winter, which I'm also not used to either. It's kind of a shock factor for me.
give us a big picture of the house. So when we modeled the house, again, our best solutions, the energy consumption would have went up, and that's just because of the detail you have. So start by the walls. What kind of insulation do you have on the walls here?
Cool. Yeah. So I'm actually going to work from the ground up because the ground was part of this exercise, which most people would just assume like it is what it is. In this instance, there's a house buried underneath us.
Okay.
That happens a lot in Detroit. And so the normal recommendation is like dig it out and replace the dirt. Well, that's a lot of work.
It is a lot of money. Yep.
Now, as an architect, I kind of advocate against basements because they flood.
They have problems. Absolutely.
They're going to have some problems. So we did a slab on grade. We actually encapsulated the house that was underneath us.
Okay.
We did what they call a shallow insulated footing. So we fully insulated the bottom envelope of our house.
Okay.
So our energy envelope starts with the bottom.
What are our value for the footing?
For the R value, so it's a 4-inch concrete slab.
Okay.
It down turns at the end and has like thick massing. And then we have a 2-inch polyiso.
Okay.
So it's like the pink board
Sure.
you get at Home Depot. It's R11.
Okay.
Is what I've got underneath the entire thing, and then it spreads out and actually like creates fins on the two sides of the house.
Okay.
So that natural like 55, 60 degrees under the soil. You know, if you dig a hole deep enough, it's not frozen.
Right. Correct. Yep.
That bubble rises up and meets the bottom of the house because we've extended the fin.
Okay.
So then we got walls. We did foam panels.
Okay.
For the whole envelope. So the walls and then the roof. So it's like you kind of imagine build the Monopoly house.
Sure. Yep.
Just like the outside is the foam panels.
Okay.
So the walls are 8 inches thick.
Okay.
We got an R40 out of that.
R40.
We
Okay.
got R40 walls.
Yep.
Then we do an insulation board on the outside that allowed us to fasten our exterior material.
Okay.
So by the time you finish the whole assembly, from drywall to my exterior, I got a 45
Okay.
on my walls. And then the roof, the panels are thicker on the roof.
Okay.
And those have an R value of 60.
Okay.
So I'm going 45
to 60. Yep.
for the whole envelope, and then I am the slab on grade with an R11 under.
When we did the load, you were about 10,000 BTUs to heat the space. It was pretty ridiculously low. And then we'll show some footage of the blower door. Lowest blower door number I've ever seen. So for a house, we were between 200 and 300 CFM50.
I didn't even expect that.
Yeah. Yep.
That is mind-boggling.
Yep. So this was definitely in a record book. It got our attention. Let's talk about some other features. So tell us about the lighting. We'll start with the lighting and work your way through the mechanicals. How does that work?
Yeah, so I mean, lighting is a huge component of everything we do. It's a bit of a balance. We got this on a nice sunny day out here. We don't use a lot of light switches during the day in here because we have so much natural daylight, and it's filtered. You know, the software that we're developing is looking at that filtered light coming in through trees.
Okay.
It's knowing how it's going to change from summer to winter, and then maximizing that window somewhere in between, right? If you just maximize it for summer light, then it's all about thermal gain, and it's not about like blocking it out. So we wanted to balance. You're taking peak conditions in like summer solstice and winter solstice, and you're balancing that.
Okay.
Now, for the lighting that you can control, there are two factors that are very, very important to us in the way that we design and architect things. And that is, one, it should all be LED fixtures.
Okay.
Like,
I
we're
agree.
not going incandescent.
Sure.
We're not screwing in old-fashioned light bulbs. So we opted to go with what are called integrated fixtures. I worked with a lighting company to kind of go through the house and to try some things out. And so one of the most important features about the lighting in the entire Cochrane home is that every light switch in the whole house is on a dimmer switch.
Okay.
And so it gives you total control over, different times of day, and it makes lighting that would otherwise feel stuck in a normal home, gives you control over it. And you find lighting that might not be useful, so on a lower dimmer setting, it's like actually just what you're looking for.
Tell us about the radiant floor system. I remember when we did the audit, it was cold outside, and we really were not uncomfortable. It was actually pretty pleasant. Tell us about that.
Yeah, this is a big factor in the slab on grade condition, and when we were planning out that whole, extended insulated slab on grade, it's really easy to do that kind of system if you're doing a radiant floor. Now, radiant heating, as you know, is the superior way.
I love radiant heating.
It's the best way to do it.
Yep.
It travels through the environment differently. It feels like more warming to the body. It stays in space.
I don't like to wear socks, so
there you go. And you walk around all winter long. Your feet are nice and toasty. So our mechanical system is all incorporated. It covers our plumbing system.
Okay.
It covers our blower units that are up on the wall.
Okay.
And it covers our in-floor radiance.
That's awesome. Yep.
So we have 3 zones to the floor. So they're the coiled loops that are filled with. We actually used it's a lower temperature system, so it runs on glycol, antifreeze, instead of water.
Okay.
So it operates at a slightly lower temp. And the zone 1 is the main house.
Okay.
Zone 2 is actually the patio space.
Okay.
So that is a heated patio. We haven't run it. You could run it for snow melts, but eventually we might actually maybe enclose that space.
Yep.
And then it's floor heating.
Yep.
And then the 3rd zone is the garage. And because that radiant heat rises, it stays within that whole airtight envelope. And so the floor of the garage primarily heats that entire suite back there.
Another thing we notice with the audit, we do indoor air quality testing. And normally when we walk into most houses, that's usually pretty bad. We normally walk into, we see high particles, high carbon dioxide, other harmful things. And we got a clean report pretty much right away. And that's another first, or it doesn't happen often. Tell us why. I'll let the viewers, I know, but tell us why.
Yeah, no, absolutely. We had to plan right out of the gate for energy recovery. And that means a blower fan that is running 24/7. You know it, I know it, as an ERV. We installed an ERV into this house because our air envelope is so tight. It can get stuffy in here. So we've got a fan constantly running, and it's exchanging the air, so it's blowing out the air and taking in fresh air at the same time. So it's mixing that. So it's not just like, it's not 100-degree air coming in right now. It's tempering it a little bit. But that allows it to feel nice and fresh in here at all times.
That's awesome. All right. So mission of the company, why did you guys build this house?
Yeah, that's my partner Scott can really elaborate on this one. It comes from a place on the heart. I came into architecture because I've always been fascinated with housing. This is the scale that means a lot to me. This is where I feel like I can make an impact on this industry for real. We're at a moment where it's a pivotal point, and we're not going to continue putting sticks and bricks together to make houses forever. Or if we do, there will be some differences to it. So I'm really excited about where this industry is going. And then from the design perspective, it's really like architects we're expensive.
Yep, absolutely.
We're expensive, and we're usually reserved for the people who have a lot of money to spend it. And so if you're getting into architecture for like a philanthropic reason, or like you want to have a meaningful impact when you work for people who have a lot of money, it really changes the narrative. We as architects believe that good design should be allocated
for everybody,
right?
Absolutely.
Like there's nothing stopping us from using natural daylight and airflow and giving you taller ceilings. It's like, why can't we allow that for everyone? And so we're looking at the algorithm as a tool. Home is particularly looking at this algorithm as a tool. If you give us a lot, we can design you a house that performs better, that is more comfortable, that provides better natural daylighting and saves you money. That sounds pretty enticing.
The fact that it was on a land bank, so for the viewers, the land bank, when property is, for whatever reason, foreclosed, tax seized, whatever, it goes back to the ownership of the city of Detroit. And the land bank, you had to purchase that. So this is vacant lot that probably sat for several years that you repurposed. And we see that you got some gardening activities going on. So this was just awesome. So we were super impressed by it. So
I tell you picked a good day to come out here. It's over 100 degrees outside. That husky doesn't look like it's over 100 degrees. He looks comfortable today.
He's super comfortable. Yeah, it's phone's been ringing off the hook in our contracting business, which brings up the point. This is this house. A big conversation is about affordable housing, sustainable housing. We fix thousands of houses a year. One of the things that we pick up, the housing is hard for people to move just because the housing stock isn't there. Interest rates are a little bit higher. There's always a housing crisis or conversation about it. Tell us how this type of project is going to help that.
Well, it's even compounded in the city of Detroit, right? And that's really what all this brought to attention. And there's a lot that we could unpack about this. This was DLBA property. And the Detroit Land Bank Authority, that's what that stands for. And the land bank, has a lot of abandoned properties that they say are builder ready. The reality is, as we talked about, there's a house buried under here. I didn't have water or sewer connections. All those costs add up real quick. So we were able to get a house done here. This is also on what's called a small lot for the city of Detroit. So This lot is only 30 feet wide by 100 feet deep.
Okay.
Now, the city of Detroit says that a buildable lot has to be 45 feet.
Okay.
So you're already breaking their own
Sure,
rules by
absolutely.
the time you start. So we had a lot of conversations with
Okay.
the city and with leadership, with planning, and the people who review drawings. And we had some really great conversations, which ultimately led to Mayor Mike Duggan cut the ribbon for this house
That's
when
awesome.
we completed
Yep.
it.
Yeah.
He came here and gave a little speech. He spent the majority of his time standing on the patio talking about that accessory dwelling unit.
Yep.
You might hear the term ADU. That's what it stands for, accessory dwelling unit. It's like an in-law suite on
Sure.
top of my
Yep.
garage. And Mike Duggan said, we need to see these all over the city. Now, the interesting part about this house was it was not supposed to be allowed, technically.
Okay.
The only reason why our ADU is allowed is because, well, I connected my house to the outbuilding with a bridge. Why? Because it's cool.
Yeah,
I thought it'd
absolutely.
be pretty cool.
Absolutely.
I mean, there
Yep.
are more reasons to,
Yep.
but then when the city took a look at it, they thought that this is a 4-bedroom, 3-bath house and let it slide. So they got that built. We have since worked with the city, worked with zoning to update their legislation so
Sure.
that these can be built in this neighborhood. And now we're seeing one across the street,
That makes
one
it
down
easier.
the road.
Okay.
So those are starting to pop up here. Then we had the kind of the shift, obviously, in leadership. Recently, Mary Sheffield has taken over, and she's out the gate shouting from the rooftops that housing is one of her topics, right? Mayor Duggan had to focus downtown, and the neighborhoods obviously want more to happen. And so now as Mary Sheffield's coming in, they're starting to talk about housing on a bigger scale. She rolled out the Detroit City RFP, which is a request for proposals for housing solutions, some opportunities. Now, 3 Squared as an architecture firm is continuing to work on that bigger picture scale because it really is a lot of the red tape. It's not the design of the house
Sure.
that's stopping us from doing a lot of these. It's the Detroit specific issues like buried houses and
Sure.
inadequate access to the utilities. You know, the city was built for 400,000 or 4 million people, and we only have about 600,000
Sure,
people
absolutely.
left.
Yep.
The utilities were built for many, many more people than we currently have living here. Which means in order to sustain that old aging infrastructure, our taxes are way higher.
Yep.
So really the housing conversation has to start at that level. And so, you know, the architecture and engineering firms that are trying to work through with the city for a solution here are realizing it's about 10% design and 90% politics.
Okay.
All right, so we have to deal with the political end. Now on the front end, that 10% design end, that's what Home's after.
Sure. Okay.
Because we can work with a number of different architecture firms, a number of different contractors, and work directly with the city in order to simplify this process, because at the end of the day, what we're doing is not really all that complicated.
Sure.
All the components of a building are still the same. We're just looking at the points that matter in a home, and instead of just building things cheaper, we're trying to take some of those energy savings
Yep.
and put that as a return back into our investment. So let's just buy better windows and let's actually put that extra sealant tape on at the edge before I board it up. And you're gonna thank yourself later because you're saving that money long term instead of just finishing cheap.
What I love about it, it also solves a workforce problem. So I do a lot of technical training, and this type of house needs skilled craftsmen. They need skilled tradesmen to actually put it together. So how long did the project take to build?
Well, the project from initiating conversations with the land bank to living here.
Set politics aside, like the actual
The construction process. So when we got the AOK, our building permit was issued, right?
Sure,
It took us 8 months from start to finish.
Okay.
And in the city of Detroit, that's pretty good.
Pretty
Like,
good,
People
yep.
do it, but with big crews. We were able to do this on a tight lot, and it is important to note we didn't bring big equipment
Okay.
here, so we didn't have like big overhead cranes or everything.
Really?
Our panels are light enough that like 2 guys could carry them.
Okay.
And so we did a lot of this with just ladders and a crew.
That's
we
awesome.
framed the entire home, like both buildings. We framed it, like drive by, it looks like a house, 5 days.
Really? That's
5 days,
awesome.
and then you start finishing the inside and cladding the outside. So yeah, we were living in it by month number 9.
That's awesome.
And now we've been able to live in this house for a full year. So I've gotten to experience the whole cycle
Yep.
throughout the year, and it's been really, really comfortable from the heated floors. And right now, I will point this out. They actually chill the floors too.
Really? Wow.
Because the fluid that's running through my system is the same system that's going through my blowers. So
Okay.
it's just coils of fluid that a fan is blowing over, or it's running through my floor.
That's awesome.
And so
Yep.
getting to those units is
That's a-
pulling
sure.
cold fluid through the floor.
Yep.
And so if you feel it right now, it's like, it's really nice.
Yeah.
And that's why the Husky, he likes to lay on the
Yep.
concrete floor all summer.
So full year, no comfort issues, been comfortable winter and summer so far here?
Yeah, honestly,
Yep.
the only tricksy part is that Michigan like transition from hot to cold,
Okay.
because the system can either be
Okay.
hot or cold.
Okay.
Right? And so if it's really hot in the morning and then you like rush to turn on the AC and then it like flips at night,
Sure.
you got that mixture zone. I think anybody who owns
That's
a
a
home
challenge that you have to
deals
deal
with
with.
that
Yep.
in those challenging moments. But honestly, I couldn't be happier. As an endeavor to design and build your own house, I think it is the most difficult thing an architect can ever do in their career.
Sure.
Lucky for me, I had an incredible team. I was surrounded by both my 3 Squared team and the home team to support this entire project. And so it gives you the confidence to really build the vision. We built something that I'm really, truly happy with. Like, is it perfect? I don't think you can make perfect, but this is,
Yeah.
like I said, we can't build them like we used to. This is as close as I'm gonna come.
Well, you definitely got a gem here. Like I said, I'm going to put it out on the record that I think this is the most efficient house in the city limit. So until we've proven otherwise, it's fact. We're going to leave it like that. Thank you for having us, man.
Good to see you, as
too.
always.
Yep. So now we're with Scott Shaw, right?
Yeah, you got it.
All right, Scott. So we just had an interview with Breck, and he gave us kind of the building science background. Before I ask you some of the questions about the physics and architecture of the building, introduce yourself, your role, and the company, which company you're representing for the collaboration for this house.
All right. Well, I am co-founder of Home with Breck
Okay.
and CEO. And my day job, keep the lights on, I work at Lawrence Technological University
Okay.
as a professor of architecture.
That's awesome.
And then as a side hustle, I have a nonprofit through which I do humanitarian.
Okay, all right, perfect. So Breck laid the foundation. We talked about all the building science features, the stuff that really interests me, like the insulation and the lighting. He went into the mechanical systems. With your software, you had quite a bit of thought about the physics of how buildings work, and you took advantage of that. Tell me about that.
Well, one of the things that we believe at Home is that great design, everyone deserves great design, right? The issue is in housing, it's a bifurcated system where most houses are built by builders or speculative developers, and it's a kind of a one-size-fits-all proposition.
Sure.
Where
Yep.
like this same house is going to be flipped around all sorts of different ways in the neighborhood. So someone's breakfast nook faces east, another one's west, another one north, and obviously that's going to impact the performance
Sure.
and feel of the space.
Yep.
But from a profit standpoint, that makes a lot
It's
of
most
sense,
efficient,
right?
absolutely,
Because rinse
yep.
and repeat. The other portion, a much smaller portion of houses, are designed by designers or architects, and they're designed to the site
Okay.
to take advantage of local views or the sun and its pattern across the sky, all these sorts of things. Unfortunately, that is a much more labor-intensive process, a
Okay.
much more expensive process, which is why very few people can actually be a part of that.
So tell us what you did with the Cochrane Home.
So with Home, what we're doing is we're developing a piece of proprietary software
Okay.
in order to embed the intelligence that a designer or an architect might bring to the table into every house,
Okay.
and to do it at a push of a button.
Okay.
So rather than have this massive expense saddled on a house to make it fit its context, we can develop a piece of software to do the same thing. Now what helps us is a lot of the things that you would design to within a local site are predictable.
Okay.
The sun, for example, is doing the same thing this year that it did last year.
Every
and
day.
Fingers crossed,
Sure.
next year as
Yep.
well,
Mhm.
right?
Yep.
And so if we know that, we can actually plan the house to that highly predictable thing.
Okay.
And so we know the path. And so now it's not a very difficult thing to say, how do we make these windows? How do we make these overhangs? How do we make the form of the home itself such that the warming effect of the sun is welcomed in the winter, but blocked out in the summer?
Okay.
And we can be incredibly precise with that. Where
Okay.
we know in our algorithm right now from 11 till 1 on this particular day it's blocked, but the very next day we know it's going to come in at 10:45 or whatever it might be.
Okay.
Right? We can do the same thing with views. We can do the same thing with ventilation, all of which are based on physics. Right? Even the positioning of a window. You push it closer to a corner, that light's going to come farther into the home. So we just developed the algorithm to help us make a lot of really smart decisions very, very quickly.
Okay.
Now, it doesn't mean we always listen to the algorithm. It's a consigliere, a guide.
Sure,
right?
absolutely, yep.
At times we could say, no, thank you very much, and we're going to go a different direction. So this house, as an example, algorithm wanted us to do a shed roof, to open it up to welcome in more southern sun than we even are.
Okay.
But you look around this neighborhood, everyone's got a centerpiece.
Okay.
And
Yep.
so we said, algorithm, that's fine, but let's go ahead and design this so it fits into its context.
Sure.
The other fun part about that is now that we've had that discussion, we can embed that intelligence in the algorithm. So the algorithm piece of software is always getting smarter. With every house we do, it's getting smarter and smarter and smarter. So the homes are getting better and better and better.
So does your algorithm, is there some type of AI component to it?
As of this time, we do use AI.
Okay.
But we are still busy with if-then statements.
Sure. Okay.
Right? Where it's like, if the sun is here, we want to block it or let it in.
Okay.
If-then statements. Once we exhaust our if-then statements, and we start to get into contested terrain where one if-then statement conflicts with another, then we can start to use AI to help us sort out the implications of what if we listen to this side, what if we listen to this side, what's the right proportion, what's the smart move here.
Okay.
So once it gets more complicated, and we're right there. Right now, we're starting to incorporate AI a bit more robustly. A, because it's advanced such an incredible amount. But B, because we're getting into contested terrain where the answer is not so obvious to our meat brains. We
Sure.
need to call in reinforcements.
The tool, is it something that others in your profession will be able to utilize, or is it strictly proprietary for your company?
No, we work with developers, we would work with architects, we would work with contractors, we work with anyone who is interested in having a house actually be sympathetic to the environment it's in, to be high quality design, etc. We're not interested in cheapness as a proposition for housing. I think we're asking some of the wrong questions with this kind of housing crisis that we're in.
Okay.
It's not just about like, oh my God, we need more houses. We actually need houses that are in tune with the environment, that aren't going to suck our planet dry, that support the lifestyles of the people inside, are tailored to the lifestyles of the people inside, are accommodating to those who might be differently abled or those who might age and have a different level of mobility.
Sure.
Like, we need houses that are designed to circumstance.
For the people. Yeah, absolutely.
Right,
Yeah.
not mass-produced housing. And the thing that boggles my mind is that mass-produced housing model is like really old, decades old. And we're still, in terms of technology of building houses, we're doing things that we did a century ago.
Sure. Yep.
And so it's not a hard thing to say, you know what, I bet there's a smarter approach out there. I bet we have better tools available so as to allow for custom homes to be designed in a way that's accessible for everyone at a price point that's accessible to the market.
That's awesome. One of the things I appreciated about the house when we did the audit, Breck was mentioning about some of the materials, how they were sustainably sourced. So tell us a little bit about the floors, the cabinets. I know we have some tiles here that has a unique story. Tell us about that.
So the first thing we do is we try to limit the number of unique materials.
Okay.
And one of the things that does for us is it allows us to take a material that's used in one place and to use the excess in another.
Okay.
So for example, the windowsills are actually lined with the bamboo that we use, the bamboo flooring, which is sustainably harvested bamboo flooring.
Okay.
We use those on the windowsills.
Okay.
It allowed us to provide a more durable finish to those sills, but also to utilize a waste product from a different part of the house.
Awesome.
Right?
Yep.
Similarly, these tiles you see before were all hand picked from Seneca tile. They're all 100% reclaimed tile. Every tile actually in this house is reclaimed.
Okay.
So as to, again, take something out of the waste stream and bring it back into utility.
When you say reclaim, be specific, like how?
So what I mean by that is Breck and Miriam went with their van down to Toledo, Ohio, where Seneca tile is, in this big grassy meadow where they dump waste tile or tile that is not needed anymore for whatever project, and they pick through it to find all this great tile.
That's awesome.
But we're also using like regionally harvested cedar throughout the house.
Sure.
You'll notice that downstairs it's exposed concrete. There's more concrete here, right?
Yep.
The idea is, can you find a way of, rather than layer, and many houses now are layers, right? You have like so many layers, and it makes the house actually really difficult to ever demount or reclaim. And so if the house is ever demolished, it basically is debris.
Sure.
Right?
Yep.
It's trash.
Yep.
But if you're starting to use processes where it's like just a single material, it becomes easier to kind of reclaim that material and use it elsewhere. And so what we do is we try whenever possible to expose the original material to not, so the concrete flooring, just let it be concrete.
Just concrete,
Just expose it. And then it also gives us that great thermal massing. So it sucks up that heat from the sun during the times when you want it to, when we're allowing that light to come in, and gives it back at night when it might be a little bit cooler.
That's awesome. Tell us about the cabinetry. You mentioned something specific about how it was designed a little bit earlier. Tell me about it.
So to make all this work, we had to consolidate all of the core functions of a house that would not want to be wide open to the world around us, or have a lot of, or need to have a lot of walls, right? So we're talking spaces like mechanical rooms, laundries, bathrooms, even the backside of a kitchen. These are also spaces where there's a lot of plumbing, pipes, ducts, conduit.
Sure.
And in a house, they're actually some of the most expensive walls in the home.
Yep.
And so rather than let these expensive walls sprawl out everywhere in the house, we use digital fabrication, CNC machine, in order to consolidate those expensive walls into the smallest possible footprint.
Okay.
And what that did for us is it freed up the rest of the house to be as light and airy and light-filled as it possibly can be, right? Because we consolidated. But to do that, we needed to make those walls incredibly precise, because what we've done is taken all the pipes of the house
and put them in one spot.
Now they're flying around past each other, and you got to make sure that there's clear distance,
absolutely,
right?
Yep.
And so behind this wall is behind this tile is actually a digitally fabricated wall that we designed, where we know where every pipe is in advance. We put that out into the digital model of the home. So this entire house has a digital twin. Right?
Okay. Yep.
So we can know in advance this pipe is going exactly here, this conduit's going exactly here. We can program that into the design of the wall. But then the other nice part is those same expensive walls are also walls that usually have things like sinks and cabinetry.
Yep.
So we just built the cabinetry using the same machine, the same technique.
Okay.
And so what you could do then is you can integrate these cupboards with the wall, because they're made with the same machine, and you plan in advance.
That's awesome.
And the client gets custom cabinetry, right, at a price point that's actually accessible.
So no more drilling through walls and finding pipes unsuspected.
Right, or hoping for the best.
Absolutely, yeah, crossing your fingers for sure. Awesome. Any other features you want to tell us about?
Well, another thing that is interesting about using the digitally fabricated core and some of the other features is that's really responsible for the reduced timeline. Okay. This house being built in 8 months as compared to 13 months, which is the average in this region. A lot of that's because these walls, and we're standing beside one very small digitally fabricated service core. There's a bigger one in the main house, obviously. These were built off-site in a shop. And then when we needed them, they came onto site, and inside a day they were installed. Okay. Right? And so that eliminates a lot of the tripping over one another.
Sure. Yep. The different
common
trades.
on construction sites, or where you're getting a product and you're like, what the heck do I do with this? I don't need it for 3-4 more weeks. Everything arrives just when you need it. It's installed very quickly, and then we move on.
Yeah. As an HVAC tech by trade, I always try to be first on the site, just so I had free reign to run my ductwork.
Of course. It makes all sense in the world.
Yep.
And these were shipped to site, I should say, open, right? Okay. So everyone could see the guts of it, et cetera.
Yep. All right, Scott, so we're on the first floor now. You were mentioning to me something very specific about the design of the home and also the ventilation. Tell me about it.
Well, one of the things that we realize is that physics is free, right? And people have been designing their houses with physics in mind for centuries, right? Air flows a certain way, the sun moves a certain way, gravity works in a certain way. And what we're doing is we're using emerging technologies to embrace those ancient traditions of building. Okay. An example of that would just be air pressure and airflow.
Sure. Yep.
So in this particular house, we introduced very low windows in the kitchen.
Okay.
And those low windows introduce air into the house, which is then pulled into the house and up by the fan that's above us, and then out a series of windows that are on the second floor.
Awesome.
Creates a natural circulation pattern. And Breck is actually building a garden on the side with a water feature right next to those windows, which is incredibly smart, because that'll introduce a cooling effect on that air that we're naturally drawing through. Again, another ancient principle, nothing we invented, but something that we embedded in a technology that allows us to embed that in every house that we'll ever do.
That's pretty interesting. We fight stack effect a lot. We're usually trying to reduce it as much as possible. I've never ever seen anybody utilize it to their strong point, like in the older housing stock in the surrounding area, we're air sealing to minimize stack effect to reduce that air and leakage into the building. Here, you're going to use stack effect to provide some kind of cooling, which is going to reduce the air conditioning load that you're going to need.
Exactly.
Yeah, so that's awesome.
It also works in the winter,
sure,
right? Because the radiant floor slab heating system, and we didn't expect this. There are supplemental units around, right? But because of this double height space, because of that fan, because heat naturally rises right through the body, this radiant floor slab heating system can actually be an effective heating element for the entire 2-story home.
That's awesome. Yep.
Which was really quite surprising to us, to be honest.
What other features do you have here on the first floor?
Well, I mean, you are noticing this very large window. One of the assets of the breezeway, again, this was something that we had to do as a part of the small lot provision in order to get the reduced setbacks on the side yard and make this to be a buildable lot. We had to reserve 400 square feet of outside space.
Okay.
The side yard, even though we pushed the house to one side, did an 8-foot setback on one side, a 4-foot setback on the other.
Wasn't enough.
That wasn't enough.
Okay. Yep.
That breezeway helps us to create
To
that
hit the mark.
necessary space. The other thing it does is you'll notice a huge window right there. That window right behind you draws an immense amount of light into this space.
Okay.
Making artificial lighting almost negligible. There's very few times during the day that they
You guys
actually
need
need it.
light. Yep.
And actually, because the city lights itself up pretty well with artificial, they can actually sponge off of that light as well,
Okay.
even at night.
Yep.
So the demands in terms of an energy are way down.
Okay. Cochrane Home is the first of its kind in this area.
Prototype. It was a test. And
Okay.
again, we're delighted that it's working as well as it is. I'm confessing to you that some of the things we planned, some of the things emerged. And
Sure.
I guess we could take credit by always working to align ourselves with physics and the way the world
Absolutely.
works.
Yep.
But there are moments where it's just like, oh, that worked out really well, better than we thought. And we are currently, I think we have like 8 to 12 houses right now on the books
docket,
that we're
sure.
looking at doing. One more here in Detroit, and then a lot within the region.
Lessons learned. What would you do different?
Oh, goodness. Oh, you took me on that. I wish I had had time to prepare on
Sure.
that. There were obviously some details that we now know that took us a minute to work out. So I
Okay.
actually think there's some things we could do to reduce that timeline.
Okay.
We did some innovations in terms of the mechanical systems that Brett can probably speak better
Sure.
about.
Okay.
But the exchange that we put forward, really smart system, very popular in Europe. Here, not as popular. And it makes it very difficult to maintain,
Sure.
etc.
Yep.
Another thing I know that we did is the Radiance floor slab heating system we used this particular system we used had to be closer to the surface
Okay.
of the
Yep.
concrete. And because of that, we weren't able to cut control joints into the concrete because we didn't want to accidentally
Sure.
nick
Yeah.
a line,
Yep.
right?
Yep.
And so because of that, you're going to see minor cracking on the
Okay.
floor.
Sure.
Breck doesn't mind. I don't think it.
Yep. Yep.
It's
Gives it some
negative.
character to it.
It gives
Yeah.
character.
Yeah. Absolutely. Yep.
But it's something that we had to embrace
Yep.
because it was going to happen.
Yep.
Concrete's going to cure. It's going to pull away.
Yep. Sure.
So I would probably advocate to use the other system so we can cut some control joints and control
Get some
that
expansion.
cracking.
Oh, yep.
There's minor details like that. Nothing major. Again, we're really excited. We guessed right a lot of times. We knew some things.
Yep.
We guessed right a couple times, and we're thrilled with the outcome.
I gotta say again, Scott, definitely appreciate you. This is a beautiful house. Thank you for letting me come in and document it. And again, it's all-time record. I've never seen an energy audit where our best solutions actually made the consumption go up. So that's unique.
I appreciate that you saying that.
No
Thank
problem.
you.
No problem.
Awesome.
Yep.